Good morning, everybody. I want to welcome you to this demonstration of Konveyor. To introduce myself, my name is Hank Scorpio. I work at the Globex Corporation. We're a large global conglomerate that doesn't do anything nefarious. And we have a retail business that's really important to our global conglomerate. And in that retail business, we have a very specific application, this retail application that is extremely important to the retail business that we have. Just a little bit of background. It's an N-tier application architecture. The middleware layer of this app is very monolithic. It's been around for years. Started in the mid-2000s. It's running all on virtual machines on vSphere, and we've got some challenges. When we deploy code, it takes months to get that code to production. We also have code deployments that have brought down the entire system. When things fail, it often takes us hours to fix, and we have trouble handling the transaction volume during peak times of the year. Because of this, a few years ago, we decided to actually start strangling this monolith to see if we can improve it and modernize it. We identified 4 key services in the app. There's a gateway service, a customer service, an order service, and an inventory service. So what we did as we started to take this modernization journey to show you where we are today is we decided that we would deploy some of these services and kind of carve them out of the monolith. And we developed a more modern front end, and we did all this using Spring Boot on Cloud Foundry. At the time, it seemed like a good idea, although now we know that Cloud Foundry is not the best choice for a platform as it's kind of dying. And so what we've done is we're actually we started to look at Kubernetes at that point. And so our last service, the inventory service that was in our N-tier application, we actually broke out into a Kubernetes cluster, and we actually started using Quarkus because we thought it was really interesting and found that it had a smaller footprint, booted faster, all those kind of great things that we wanted for our cloud native environment. And so we busted out the inventory service. We backed it with a Postgres database. Now that we were on Kubernetes, we could actually keep our state on the Kubernetes cluster. The problem we ran into is we've kind of manually deployed that inventory application to our developers in their dev environment, and we're not going to be able to promote this to production unless we automate the entire thing. So this is where we're at, and it's not a very good spot. We have multiple platforms proliferating. We have various ways in which we deploy the software, and we're not really realizing the improvements and the efficiencies that we want. So ideally, what I'd like to see as Hank Scorpio is everything running on Kubernetes. And we know that on the database layer, specifically with Oracle, this might mean starting in development like this and eventually getting to production running our Oracle database on there. But we want to do this so that we can get all the benefits of Kubernetes, horizontal pod scaling, rollout and rollback that's automated, bin packing for more efficiency, self-healing, service discovery, all the things that Kubernetes gives you. We want to leverage a GitOps paradigm so that we could we could improve our software delivery performance in those areas you see listed on the right there. And we want to simplify our operations. We want to, basically have one platform that we have to worry about instead of 3. But the question is, how are we going to do this? Because I've got these applications here, and so thankfully we've got the Konveyor team here, a few folks from the Konveyor team that are going to help us. So Ramon, I'm curious, where do we start?
So I would say that the first thing would be to assess all the different components from your application. That's it. Next slide. So we will be using the Tackle and Pathfinder for that. And the idea is to just work on the container suitability for each one of them. So since you have this legacy piece in there, I would say we should focus on there, analyze the source code, and try to find anything that might prevent the application from running in containers. And in case we find something odd in there, and I know we will because I already had some conversations with your architects, refactor the source code to make it suitable for containers and more cloud-friendly than it is right now.
Nice, that's great. What do I do about this this database piece here? Pick up again.
So yes, I'm here. So we have this database. I mean, in your infrastructure, you may have several workloads that are not ready to be put into containers initially. They require some transformation. In some cases, this transformation is going to take quite some time, but you still want them next to your workloads that are already containerized. So what we're doing here is that we're bringing the database as it is, as a VM, bringing the full VM into Kubernetes, using capability for Kubernetes called KubeVirt that enables being able to run VMs in a Kubernetes cluster. So this way, what we're going to do is we're going to rehost this VM into Kubernetes cluster, so it can be initially used. It can be cloned and added to any kind of pipelines that you want to use in your cluster, and you could manage it just like any other container in your Kubernetes cluster, making it easy for security, for administration, and for operational purposes. If you have any other component like this, like let's say an enterprise service bus or a rules management engine that is old and you still want to keep it while you're modernizing the rest of the application, you could do it this way. So we are leveraging this capability to be able to do it.
Thanks, Miguel. We're trying to shorten the intro. Shorten it. Okay, awesome. So now I can move my Oracle database over super easy. What about all these Cloud Foundry apps? Ashok?
Sure. So one of the things you need to do for your Cloud Foundry apps is to create all the Kubernetes artifacts required, like from your CI/CD pipelines to the YAMLs, and if you're interested in help charts and more. And you can use MotoCube to create all those artifacts for you so that you have a very cloud-native experience. We can have a demo of that too.
Cool, cool. Yeah, that sounds too good to be true. I'm definitely going to have to see it to believe it. And what about this inventory app? Marco, you guys told me about this Crane project.
Yeah, so this is already running on Kubernetes, but it's been manually deployed. It has all kinds of hard-coded value in the deployments, and we want to automate all that. So using Crane, then we're just going to clean this up, push that to Git, and get that like to have an automated deployment model and follow our GitOps principles now in the future.
Nice. So we're going to assess, analyze, refactor, rehost, and replatform everything onto Cube. It sounds too good to be true. So I have to ask you for a demo because, oh, sorry, Hank Scorpio does not believe you that you can do all of what you just said. So,
okay, let's get to it, because definitely this is not a staged marketing presentation at all. So just 1 second. Sharing my screen right now. Can you see it now?
Yeah, we see it.
Scorpio?
Is this the Tackle project?
Yeah, that's it. So yeah, let's start from the beginning. We were saying that we will be assessing all the different components from the application. So it looks like your architects already did their homework and loaded up the whole application inventory within the application inventory components from Tackle. So it can be done manually, but and also with a CSV import. I would bet that they did it in that way. So you can give them a raise because of this proactivity. So the thing is, with the application inventory, the idea is to have a holistic view of the whole application landscape that needs to be migrated on the migration initiative. And with this, you're able to classify and basically catalog the different application types, applying different things. So
I see. You've got some of the other business units you've been working with at Globex. We might want to hide some of them. I don't think you're supposed to know about some of those.
Yeah, well, maybe they were a bit too. I don't know. Well, I don't know what to say. So let me filter this thing. Let's focus on the retail business service. And here we have all the different components we were discussing. And the cool thing about the application inventory is that it has a extensible tagging model that allows you to classify the applications in as many dimensions as you might want. So if we open the details on each one of these components, we can see we are using tags related to the technology stack that we've been using for each one of the components. So we have the gateway microservice, which is Java and Spring Boot, the inventory microservice, Java, Quarkus, PostgreSQL. We will be focusing on this legacy customer management piece that we will be assessing. We already thought this could be problematic because this is the thing that is not currently running on containers. So we have Java, Tomcat, Oracle. The cool thing about the tagging model is that it is extensible. So we added another tag type regarding or addressing the different libraries that you have in-house. So it seems like this application uses the custom configuration library. So that's something that we will definitely need to take a look into. So do you want to go into the
Yeah, that's interesting. So basically, I know you were talking to some of our architects on this customer management. So you're saying you can see kind of the specific things that are going to pose risks and the dependencies between the different apps. Okay.
Exactly. So that's what the assessment is for. So let's get into it. We already had a couple of beers with your architects and work on some of these applications. So we already did the assessment for this legacy order management. So we will do it as quick as possible. So the idea here, Mr. Scorpio, it is you. The idea here is to do a questionnaire-driven assessment in order to tackle all the different aspects of the application landscape. So meaning application lifecycle management, technology, operation, everything that revolves around the application is addressed during this questionnaire. So we will skip through it. There are questions of lots of kinds, and they are organized in different areas, like application details, dependencies, architecture, observability, and cross-cutting concerns. We will skip through this, and we will get straight into the review. So the idea of the review is that it, given the or through the different answers that you have provided to the question, it is able to identify any risks that might prevent your application from being containerized. So the whole focus of this assessment is to see how suitable an application is for containerization.
So I probably want to get rid of that medium and high. Yeah.
Yeah, that's it. Let's drill down to see what these medium and high things are. And at the bottom of the screen, we have this list of identified risks through the different answers. So it looks like your application handles service discovery in a way that is not compatible with Kubernetes. That makes sense because it's currently deployed on a legacy platform. It seems like you guys don't have that much experience on application containerization, but that's why we are here. And the most interesting thing I would say is that the application is being configured using multiple configuration files in multiple file system locations. And that's something that we already knew. That's why that tag was there, identifying that it uses this corporate configuration library of yours. So we already had a chat with your architects. So it seems you're doing something a bit, old-fashioned here. You're loading application configuration files from static paths within the file system, and that is an anti-pattern for a cloud-friendly application. So that's
yeah. I remember this coming up years ago. There was this developer. His name started with an R, and he had been putting those in his local file system.
Yeah.
Maybe we'll find out about him later.
You should definitely fire whoever did this thing, but that's another discussion.
Okay.
Okay, so let's get to it. So we identified this series of risks. The cool thing about the review is that it provides you information for you to do, let's say, an informed decision on what will be the best or the best migration strategy for a given application. So since we need to change some source code to adapt it, I would say the proposed action will be to refactor, to adjust the source code for a containers runtime environment, and in this case, especially Kubernetes. The forward estimate, I think, will be small because we will only be removing any usage of these libraries. I know this application is very critical to your business, and I would say the priorities should be as high as possible. So we submit the review, and everything gets stored in the system, so we can consult it later on.
Great.
So
cool. Yeah. So now that I've got that done, like you mentioned, that we can actually go start looking into the application itself to see what changes need to be made, right?
Exactly. So for that, we will be using the analysis component from Tackle. So this analysis component comes from the Windup project, which is the upstream of the migration toolkit for applications in Red Hat. And we're currently contributing this piece of code to the Konveyor community. So right now, we don't have a full integration between the application inventory and this analysis bit. In the future, what we want to have is a seamless user experience here. So we could run an analysis in the same way that right now we are running an assessment by just choosing an application and clicking on analyze. So that's not the case here. Yeah, that's not the case here, but allow me to do some magic, and let's switch to the other application. There are a few concepts that are going to disappear. So right now I need to create a project.
Okay, so this will all be done later when I just click analyze straight from the other tackle interface.
This will be completely automatic. Absolutely. Nice. So one of the things that will change right now, we need to upload the actual application source code or binaries to start the whole analysis process. In the future, what we want to do is to, or what we're working towards, is to have a full integration with from Windup and the application inventory with source code repositories and corporate artifact repositories to enable these tools to download the source code or the artifacts right away without having to upload them manually.
Okay, cool.
So once I have uploaded, I can start setting the migration path that we want to use. So I think you will be keeping the Tomcat for now. So no opportunity for me to sell you some cool application server like EAP.
Yeah, I think we're going to stick with Tomcat on this app for now. But
okay, so let's focus on containerization for sure. And since we're moving the application towards container, let's add Linux in there just in case you have some funky paths in there, something that is somehow coupled with Windows from previous iterations. And I kind of feel like you want to get rid of the cost of the potential licensing of the Oracle JDK.
Yeah, absolutely. Our Doomsday Device project is already paying too much to Oracle, so we want to get.
I think we agreed on not mentioning the Doomsday Device, but yeah, whatever. Okay, so choosing OpenJDK as well, and we are good to go. Containerization, Linux, OpenJDK. Let's move on. So next step will be to select the packages from your application that you want to have analyzed. So instead of having everything analyzed, we will focus on just the business-related packaging, which will be io.conveyor. It's funny because you use the same packaging that we do. So it kind of feels like this is some sort of staged marketing demo, but it isn't.
No, absolutely not.
Okay, so I choose that. And moving on, yeah, custom roles. So we were discussing that we already had some conversations with your architects. We already identified that there is a problematic configuration library being used by the applications, and we want to get rid of that for sure. So what we did here was to develop a custom rule that detects that the usage of that custom library and provide some hints on how to remove it, to actually remove it from the source code. So we can add this custom rule to the analysis. I didn't mention it before, but this tackle analysis system or tool is based on a rules engine. We already ship some rules out of the box with the tools, but if you want to extend it and just adapt it to a more custom situation like you will find on any organization, you can do that. And that's exactly what we're doing here.
Got it. So you've added rules to catch those cloud readiness issues we found in the tackle assessment, yeah?
That's it, exactly. So I just added it. Moving forward, we won't be using any custom labels. There is a ton of options. Come on, you can do it. There is a ton of additional options here. We will stick to the target and the migration path that we discussed. So last step will be to review the whole configuration of the analysis that we have made and just run the analysis. So since I know you are a very busy man, I already run the analysis beforehand and have the results here.
Oh, that's great.
So let's see the reports that get generated. So this is the kind of reports that the tackle analysis tool generates. We can drill down into each one of the applications. In this case, we only analyze one. And the most interesting thing that you get from here is the issues tab for sure. This shows you the list of issues that might prevent an application from running on the designated target runtime. So in this case, these are the things that might prevent the application to run on a cloud environment within containers.
Oh, okay. So there's the hard-coded IP that it caught, but also found that file system error, yeah?
That's it. The file system might be related to the libraries. We are analyzing the binaries. So if the binary has the library embedded, there's some stuff in there that can be caught as well. But as you can see, we also fired this custom rule that we added to the analysis. So we can see there is some occurrence in this persistent config a class. We have a hint, the whole explanation of what needs to be done to resolve this issue. And if we click on the class, we can see right away where the issue is happening. Where are we using this application configuration class that is doing some funny stuff that shouldn't be done in a cloud environment?
That's great. That's great. So it tells me exactly. It'd be great if I could actually change it now on my application. So is there something I could do to actually go automate that?
Well, automate for the moment, no. It's something we're already working on. But the idea is to have some assistance through the whole migration process. So you definitely have some
kind of like Clippy, like he just comes in and says, "Let me fix your code for you."
It's yeah, something like that, but less annoying, I would say.
Okay.
So yeah, you got me by surprise there. So yeah, so we are running a web console right now. We cannot change the source code here. So what we thought to make this a bit more usable, instead of having to switch between this window and your IDE of choice, we developed a series of IDE plugins for the most popular IDEs out there. So let me switch to my IDE right now. I already downloaded the source code for the project. I have it open here on my IDE, and I already installed the MTA plugin. The MTA plugin is the current distribution that we have for this wind-up project plugin. We don't have any upstream distribution just yet of these plugins, but we will once everything gets completely contributed to tackle. So don't worry about this thing. So.
Okay.
Moving on, regarding the plugin, if you get into it, you can run a local analysis within your IDE and see what's wrong and what needs to be changed right into your source code. So we have the same configuration here. We will be looking for the cloud readiness, Linux, OpenJDK migration path, and we also added the custom rules. So we could click on analyze, and it will run the analysis. Just for the sake of time, we already run the analysis here, and we can, from the IDE, we can consume the same report that we had on the web console. But the cool thing is that we can get hints of what needs to be changed right into our source code. So for the customer's Tomcat application, if I drill down, I will see that for this persistent config class, there seem to be a couple of hints. Legacy configuration, this is the rule, that the issue that we saw. So I can see that this is happening in this line in my source code. And if I need to know what needs to be changed, I can get into the details, and I can basically put it one side to side and start coding what needs to be changed. So since it's not that much, we can do some light coding, and I hope not to break anything, especially nothing related to the Doomsday device. And it seems like we need to add this property source to have a more, let's say, standard approach to configuration management in Spring Framework that will allow us to have an externalized approach to configuration and use things like config maps in the deployment of this application in containers. We need to also add this environment class to load up, being able to load up in memory the different options. We definitely need to get rid of these things, of the occurrences of this configuration class. You need to fire that architect that put this thing in here for sure. And it seems like there is some mismatch in here in the config variable. So let's see, organize. Whoa. Wrong configuration. That's it. We organize the imports, and we used Spring Framework implementation, and bam, we're good to go.
Great. So now I was able to kind of find the problem that would keep me from containerizing, right, using a local file system, and then I was able to basically go into my IDE, get a hint, and then replace it.
Yeah, that's it. And now the application is ready to go and ready to be containerized. So yeah, we definitely have the source code ready to go. The next step, the next logical step in the migration process would be to generate all the different artifacts, deployment manifest to have this application deployed on Kubernetes, and also the images, the whole thing that actually makes this application run on containers on top of Kubernetes. And for that, we have the Move to Kube project. And I have my colleague Ashok here that can explain it to you.
Thanks for that, Ramon. So Ashok, so now Move to Kube can actually help generate all the things I need to run on Kubernetes. But are you going to do that with this app, or are you going to do that with like the Cloud Foundry pieces that you mentioned earlier?
Sure. Let's go ahead and do it with both of them together. We have 3 components that you're running in your Cloud Foundry. You have your front-end component, and you have your gateway and order services running in Cloud Foundry. In addition to that, you have your app, which you have just modernized with Tackle. So let's take all of that and try to move it to Kubernetes and create the artifacts for it. For that, let me invite Akash to show a quick demo of it. Akash, if you can share your screen. So what we are going to do is to first check out the repository containing the modified files. So let's look at this E2E demo apps folder. And here we have 2 folders. One is your front end, which is the Patternfly React seed, and the second is your backend services. If you go into your backend services, the microservices demo folder, you have multiple folders, each containing a different component. You have your customers component, which you just saw that was modernized using Tackle, and then you have your orders component and the gateway component, which we are.
Yeah, so the orders and the gateway component, those were previously being deployed on Cloud Foundry, but we want to move those over to Kubernetes, right?
Absolutely, that's right.
Yeah. Okay.
So what we are going to do now is to take this E2E demo apps folder and give it to Move to Kube and see what it can do for us. So what we are going to do is to call Move to Kube, and then we are going to call the Move to Kube transform command with this particular folder. And to specific to your settings, we are going to give you a config which has information about your ingress and other information that are required. And then we are going to invoke it. What it will do is it will automatically go and try and find the different components here and the type of components, like whether it's Java, Node.js, or any other component that you have. And then it tries to figure out what is the best way to translate. It tries to create, okay, can I create a Docker file for it? What should be the multi-stage Docker file looking like? And what should be the configuration of it? So once it comes back to us, let's see what it has generated for us.
Okay, great. Yeah, so it's basically looking at my source code and then determining everything required to run on Kube, huh?
That is correct.
Huh. Interesting. I'll be interested to see what it comes back with.
Absolutely. So you can have a more elaborate process where you have your plan generated so that you can bounce it with your architect and then evaluate it and move it further. But there is also a very simple, simplified one-line flow. That is what we are seeing.
Oh, okay. Nice. We're going to need to tune your semaphores here to make this run faster.
Yeah. Oh, actually, we can give detailed logs. So you're just hiding all those logs with the panic.
Yeah, I saw that.
And we will have a UI demo by the next Thursday. So we will we have a.
So while we're going through this, so right now it's running, but normally you wouldn't necessarily run this through the command line. I'm assuming plug this into like my pipeline that I already have built, right?
You can definitely do that. There are 2 choices you have. Either you do it as a one-time process, and then you review it and deploy it as part of your CI/CD pipelines, or you can make this if you want to make it as part of your CI/CD pipelines. Even with Move to Kube, you can do that.
Okay, great. All right, we'll have to figure out how to speed this piece up.
Yeah.
It didn't take this long yesterday, did it?
Oh, we did it as 2-step process. We did the plan and then the transform separately, so that it looked we could explain through it. Yeah. But yeah. Like, speed it up. Yeah, we should be able to speed it up.
Okay. Yeah, do you think it's maybe the number of apps in that folder or something? Maybe. I don't know.
Oh, it's probably okay. Probably the .git folder is there, and which has a lot of files in each of the repos. So we just strip that out.
Remove that. Okay.
Yeah. Or we can even do it offline and show the output, but it never generated. Oh, there it goes.
There you go.
Okay, so now we have created the output. Let's have a look at the output here. So let's go to the My Project folder, which it has created with all the artifacts. So we will bring it up in VS Code. Okay, so now let's look at what it has created. So firstly, let's go into the source folder. The source folder has the exact folders which you had given to MotoCube, and in those folders, it has augmented them with the containerization files that needs to be part of the source code, like your Docker files for your Node.js app and for your gateway app and the orders app. And if you notice the Docker files, it has your specific configuration of your application name, the jar files it generate, the Java versions, and all of that seeded in the Docker files. Once we have the Docker files, the next things that we need to do is to have some scripts which can help you build the images and push the images. To speed up the process, we have already built the images offline, and we have also pushed it into registry. The third thing that you need is the YAMLs for deploying your application to Kubernetes. So here are the YAMLs for your different components, the gateway service, the orders, and the front end. It has created your deployment and service and the ingress components for you. So once we have that, the next step is to just deploy this into Kubernetes. So what we are going to do for that is we will just use the kubectl commands to deploy. So we are going to go to the command line again, and we have already logged in using the kubeconfig. So we are just going to apply the YAMLs folder that we just saw.
Oh, great. So if I didn't have this, I'd have to do all that manually, right? Generating all those YAML files and figuring out how to build and deploy my app there. And this is kind of automating all that, speeding that up.
Absolutely. You'll have to create for each of your component, understand what is the best way to create the Docker file, understand your standards, understand your base image and all of it. Now you can automate all of that with just MotoCube.
And I could have my ops team, insert their own customizations in there too, right? If they have specific things that they want us to use.
Exactly. So for example, you need to have a few annotations that are specific to your configurations. You can all import that into MotoCube.
Great. Oh, cool. I see the services are running. Yeah.
Right. So as we have deployed the different services, you can see all the services up and running and the ingress being created for them. So let's take one of the ingresses and see how it works. So what we are going to do is to just trigger the UI. So now we have triggered the UI ingress, and it has brought up the page for us. And it has the customers, orders, and the products that are being listed.
Very nice. So, very nice. Although you broke my Simpsons theme with Monkey Island, but we'll let it slide.
So
great.
What we were able to do is
my fault.
Go ahead. Sure.
Yeah. So we were able to take all your source code and create all the artifacts that you require for deploying. Now you have the artifacts for deploying, but you might want to automate how your DevOps process happens. Like, for example, whenever you do a check-in, you might want the images to be built and pushed. So if you look at the artifacts that MotoCube has generated, it also creates your Tecton pipelines or build configs if you're using OpenShell. And all those can be used to automate your CI/CD pipelines for you.
Very cool.
So now that you have taken your app and deployed to Kubernetes, you might want to do something about your database too, right?
Yeah, that's what I was going to ask. I know when we initially went through this, we talked about containerizing that Tomcat application, which we've done now. We've moved the Cloud Foundry services over to Kubernetes now, but we had that Oracle database hanging out there. What am I going to do with that? Miguel, you told me I could actually just move that over. Is that something you could show me how this works? VMs on Kubernetes, I just don't believe it.
So yeah, I mean, the thing is that Kubernetes is a cluster that can manage resources, normally as pods, and in those pods you could put containers, but you could also put VMs. So this is what we're doing. So let me share my screen and show you how it would be. Okay, so you could run this capability called KubeVirt that can enable you to run virtual machines in a Kubernetes cluster. So in this case, I'm using OpenShift as the Kubernetes cluster, and I have OpenShift virtualization, which is a distribution of KubeVirt provided by Red Hat, and I'm running it here, and that's all you need. This is storage, networking, and compute provided by OpenShift or Kubernetes, and here I install Forklift, the Konveyor Forklift operator. The Konveyor Forklift operator provides, in this case, I'm showing you the UI. So in the UI, you have the provider, and this is where you are going to take the VMs from and take the VMs to. So this is the target provider, which is the same Kubernetes cluster that I'm installing this tool into, Forklift. And then you have the source. The source is going to be your VMware environment where you probably have all your VMs. You told me your Oracle database is in this vCenter environment, so I just configure it here. And then we have this VM that is connected to several networks and has several disks. So what I did already to save time is that I chose the network of the VM in VMware, and I already selected a network in Kubernetes that is equivalent to this network. That is the one that we are going to use afterwards. And then same thing for storage. You're using some storage in your environment, in your VMware environment that is NFS, not very fast and quite enough for what we're doing with this database. So we chose this standard storage class that is also backed by NFS. So it's equivalent. So we have established the equivalences, the mappings. And now what we do is that we can bring the VM from wherever we have it to a new place. So for that, we can create a plan. I can create a Forklift plan. I have one running here, but I'm going to create a new one. And the description, the Scorpia database, right?
Yeah.
We're going to move the Scorpia database, and we are going to have this running from vCenter to the Kubernetes provider that we have selected. And then we can create a namespace for this. So we're going to create the Scorpia project in Kubernetes. So we can drop the VM here. We click next. We just have to select the right VM. We choose the cluster that we are going to use within this vCenter, and then we can filter the VMs. You see that we have several signs here. This is because we check the VMs before changing anything. So we know that this VM is having a DNS-enabled cluster. The VM, we should change the name because it has spaces and it's not used by Kubernetes. And change block tracking is not enabled, so we'll have to shut down the VM, copy the data, and power it up. What we call a cold migration. So let me select a VM where we have the database, and I can select this VM that has the database. And I can see I cannot do, again, same thing here. I cannot do change block tracking. So I will have to do a cold migration.
Okay, so when you mapped your networks and storage earlier, like you mapped those, now I'm able to select them here. That keeps me from like shooting myself in the foot and migrating a VM over where there's no network or storage available, right?
Exactly. And also you could reuse this if you want to migrate more than one VM. Let's say you want to migrate 100 VMs, you could do it like that because you have already established the equivalences. So this helps you establish the equivalence before, test it, and then if you want to run it for 100 VMs, you could do it just in one single step.
All right, that'll be for the next demo.
Yeah, and same thing with the storage. I mean, you have to select equivalent storage in source and target. So you have to select as many data stores as you're using and assign the right storage classes in the target. And then, as I said, we're going to use cold migration here. I mean, we could copy the data while the VM is running if the cluster in the source is properly configured, which is not the case. So we're going to go next, and then we could automate some tasks like changing things in the load balancer or in the DNS, or even in the VM, changing things in the VM, like removing the agents that we do not need in the target environment. We just check everything, we finish, and the plan is ready to be run. Right now, it's checking some things on the VM on the source, and once the check is completed, we will change from unknown to ready. and then we'll be able to run it and have the VM migrated. So this is how we can bring the VM into your Kubernetes cluster. Then and then you will see the VM right there. So
that's great. So then I could start to use, config maps and Argo CD and all that sort of stuff right with my virtual machine, where I couldn't really do that in my end-tier environment.
Exactly. That's interesting, because you could apply one config map to your VM, 1, 2, or as many as you want, and change things within the VM at boot time by just applying to the config map what you need. And that config map could be defined in your Argo CD pipeline, so you can do GitOps with these VMs, because they are just another Kubernetes object.
Yeah, that's great. That should really speed up, especially our development times, because I know they have struggles getting database changes done quickly in their dev environment for testing. So
plus they could clone it themselves and just try new changes with new VMs with those databases for testing, and then delete them when they're done and start again whenever they want. So it really empowers the developers.
That's great. That's great. So it seems like where we're at now is we've kind of we refactored the app. We rehosted this Oracle database. Ashok showed us how we could move the gateway and order service over. I think that just leaves us with one thing left, Marco. So no pressure, but you told me Crane can actually take my existing app and automate it into a GitOps method. Sounds too good to be true.
So let me show you that, James. Give me 1 second. Hank.
Mr. Scorpio for you.
You can call me Hank.
Okay, so so or as you remember, right, like the inventory application was deployed manually, and there's all kinds of hard-coded things into this deployment or in our deployment file. So what we want is to clean this up using Crane, then push that to Git, and then get this automatically provisioned, so we have an automated deployment, and then we can over time promote from dev to QE to prod and get more efficient as we're building code. So first thing I'm going to do is to use Crane to export the current manifest that we have in this application, which is my source inventory. Right now, this application is running in the inventory source namespace. So here, I'm exporting all the Kubernetes manifest. We'll give that a minute. And then this will generate a bunch of YAML files, which is the definition of our deployments. And this is what we want to clean up and then push to Git. So to do that, we're going to use another Crane command, which is Crane transform. And transform is a very powerful tool that can help me do all kinds of things to those Kubernetes manifests. But in this case, we're using a set of plugins that will help me clean this up. And we'll also generate some transform files or JSON patches, which so instead of modifying directly those files, in case we want to audit exactly what is happening and or roll back any modification, then we don't want to change those files. We just want to generate some JSON patches to be applied, right, and then push that to Git. So now here in my transform folder, I have all the things that will be modified that the Crane transform command found that needs to be changed or fixed or improved, so that we are
So if there's something like so for example, like in the ingress inventory one you have there, that's like if there's something environment specific that needs to get patched to move it to this new namespace, that's where that would happen.
Exactly. So things like service cluster IPs or some metadata information that is specific to this deployment on this specific cluster or this specific namespace. So those things should be automated and not be hard-coded into deployment into the manifest, right?
I get it.
So once we have all this cleaned up, then we want to push that to Git so that we can automatically deploy that using Argo CD. So Argo CD will look at our Git repository, and this is how now we will automate that in the future. So to do that, we're going to use Crane Apply, and Crane Apply will apply actually the transform patches to the original manifest and then push that to Git. So as you see, it's very simplistic. Now everything is in Git here. And I have a resource folder with all my new manifests that are cleaned up, ready to go, and ready to be pushed to my Git repository. So now we're going to add that to Git. I'll commit those files and push them, and I'm ready to test the deployment of this. There's only one thing left before I can get Argo CD to now provision this. Is I need to migrate the state. As you remember, like there's a database in there that has data in it.
And Postgres database.
yeah, I need that data to be copied over. So as this is like containing like all the products we have, you guys have, and it's a fairly big database. I already transferred that, and the way I've done this is I've used the crane transfer PVC command, which actually look in the source namespace and the target namespace and just copy the PV or the PVCs from source to destination. And
So you did that before this, right? Before this.
Yeah.
Okay.
Just a matter to not wait like multiple hours as we're copying
because
bytes of data, right? Like,
I mean,
we have so many products.
Yeah, Globex retail is definitely rivaling Amazon at this point, I think, with our scale. So that's good to know.
So in this Argo CD file, now I have defined what I want this application to be, and in the future, so Argo will look at this Git repository and will actually provision now into automatically from Git to my inventory production namespace. And all I have to do is to create this application in Argo CD, and we can look at Argo provisioning this. And the beauty now from this point on is every time I want to make changes, all I have to do is to make those changes to Git, and Argo will keep provisioning for me automatically any change I make, and I can roll back, and I have a fully automated deployment. So let's do that. Let's push that, and then I'm just going to share the Argo UI, sorry.
Oh, great.
So here you'll see in a minute, like Argo CD now pick this up from Git automatically. And if I click on it, I'll see all the resources from my Kubernetes manifest that are not getting provisioned.
There's the PVC,
yeah. So this was already pre-copied over. So this is all getting attached together now. And in a minute, I'm going to have my app running when the syncing process has been completed. And from this point on, I can.
So now my developers for the inventory service would just do commits to Git, and then everything else would flow.
Yeah, exactly.
Ah, great.
So cool. It's the same app, same thing, but now in a fully automated manner that is getting provisioned on Kubernetes, and you can provision that to one cluster or another, and then promote from one cluster to another as you are ready to get from dev to production.
Awesome, great demo. Very cool. So just to kind of wrap things up after that demo, so this is the state we're in now. Now we have everything running on Kubernetes. We've been able to modernize all those pieces, kind of get all the benefits of Kubernetes. So now we can use GitOps all the way down to our VMs running database VMs all the way through the rest of our services. So we get all the benefits of Kubernetes there, and we're leveraging this GitOps paradigm. Now in the future, we're going to actually show how you can deploy a tool called Polaris and start measuring your software delivery performance now that you're running on Kubernetes. So how quickly you're able to actually get code to production and those things. So we'll be able to more effectively measure our software delivery performance in the future. And all this is running on a single platform. So we no longer have a virtualization platform, a container, and two different container platforms. So we're running on Kubernetes consolidated. So hopefully you enjoyed this demo. I want to thank the folks who put this together. A lot of people working over the last few weeks to kind of get the environment ready, all the way to getting the tools in here. These are the tools that were mentioned. If it's an easy way to look at them, are across rehosting, replatforming, and refactoring. And if you're interested in joining us on the Konveyor community, our goal is to build these tools that help you rehost, replatform, and refactor your apps to Kube. And you can join us here. We're on Konveyor on Kubernetes Slack. You can learn more by watching meetups that we hold. And if you have something you want to talk about on a meetup, feel free to email us and get involved. Thanks again to the presenters and everybody who put effort into this. And with that, it's a wrap.